Hi, this is Mrs. Mancuso, and this video is to help you review redox in chemistry. So, I am going to go through some Regents questions and help you along. So, the first one here says, given the reaction, 2 sodiums plus 2 water makes 2 sodium ions and 2 hydroxide ions and 2 hydrogen gases. Well, 1 hydrogen gas molecule, it's diatomic. So, here is our formula right up here. And the first question, what substance is oxidized? So oxidation is losing electrons. So we want to go up here, and metals often oxidize. They're on the left side of the periodic table, meaning they have very few valence electrons, so they easily lose those valence electrons. Here is sodium, and it's going from a 0 to a +1, and that's showing that it oxidizes. Now, another thing that I want to make sure that you understand is when you are asked a question like this, what substance is oxidized, you really only have 2 options here. There are only 2 substances before the arrow. So those are the only things that you can choose. And over here, hydrogen is a +1, and over here it is a 0, so that means that it is going down, it is reduced. And oxygen right here is a -2, and over here it is also a -2. So oxygen really isn't a choice, it is our spectator ion. The hydrogen is reduced, so we want to pick the sodium. And we want to make sure that we are choosing the one from the reactant side. We do not want to choose the ion because that is a product. It's asking us what is oxidized, so we need to make sure that we're choosing a reactant. All right, the next one, what change occurs when an Sn+2 ion is oxidized? So if it has become Sn+2, it becomes that +2 because it lost 2 negatives. And the negatives are the electrons, so 2 electrons have been lost when it was oxidized. All right, going down to the next one. Which half reaction shows both the conservation of mass and the conservation of charge? So basically, what a question like this is asking us is which one is balanced properly. So we go over here, 2 chlorines, 2 chlorines. That's showing us the mass is conserved. Now we check the charge. 2 negatives, 2 negatives. So A is actually our answer choice. But I want to go through and I want to show you why the other ones are wrong. So let me take a red pen, make this a little bit brighter. Here we have 2 chlorines on the left and only 1 chlorine on this side. So that makes that not a choice. They are not balanced. 2 bromines, 2 bromines. So the atoms are balanced. Now let's add up the charges and see if they're balanced. 2 negatives gives me a -2. Plus 2 more negatives is another -2, so that's -4. And over on this side is a 0. That is not equal, so that is not an answer choice. Here, 1 bromine, here 2 bromines. Those are not equal, so that is not a choice. So this was our best choice because both the atoms were balanced and the charges. The next one, in an electrolytic cell. So when you see that, I want you to remind yourself electrolytic are the ones that require a battery. To which electrode will a positive ion migrate and undergo reduction? So there's a couple ways that you can think about your answer, and you should always think about your answer before you go and look at these choices. First of all, reduction always happens at the cathode. Regardless of the type of electrochemical cell, the cathode is always the site of reduction. Another little trick here, they've told us that the positive ion is going to migrate towards it. A positive is going to be attracted to a negative, and that tells us both parts of this answer. We want the cathode, and we want the negative charge. And you might remember that a battery has reversed the charge and made it negative. All right, the next question, which half reaction correctly represents reduction? We remind us of that saying, oil rig, oxidation is losing, reduction is gaining electrons. So if you're gaining electrons, you want to make sure that you're showing the electrons before the arrow. all of these answer choices have shown the gaining of electrons before the arrow. So now what it's really about is seeing which one has the charge correctly. So this one has a positive 2 and a negative 2, and it comes out to 0. That is correct, so that is going to be our answer choice. Let's go through and see what's wrong about these. A positive 2 and a negative 1 should come out to a positive 1, not a positive 3. So that's not a choice. A 0 and a negative 2 gives me a negative 2 on this side, and this side has a positive 2. Those are not equal, so that's not a choice. Here we have a 0 and a negative 1, and over here, this should be a negative 1, not a positive 3. So you're really looking to see which one has the charges equal on the two sides. All right, over to our next question. Here is a diagram. It's really typical for them to give you diagrams. It says it represents a voltaic cell. You notice it as a voltaic cell because right away you see that salt bridge and you notice that there is no battery. The next thing you always want to do when viewing a voltaic cell is go to table J and look up these two metals. Zinc is higher on table J, so I right away want to label that my anox. And this side is lower, meaning it is going to be reduced, so that is going to be my red cat. This stands for the anode, the site of oxidation. This stands for the cathode, the site of reduction. Oxidation is losing electrons, so my electrons would go through the wire in this direction. All right, now I am ready. Oh, another thing I always like to do is draw arrows to show the reaction. Oxidation is losing, so A is going to decrease in mass. This side is gaining, so the arrow would go this direction, showing the ions becoming atoms, and this side is going to gain in mass. I like to say the red cat gets fat. Which statement correctly describes the direction of flow for the ions in this cell when the switch is closed? So, ions are what move up here through this salt bridge, and they actually move in both directions. So, ions move through the salt bridge in both directions. If they do not move, they tend to build up and polarize, become too abundant on one side. When the switch is closed, which group of letters correctly represents the direction of electron flow? So electrons always go from the anode to the cathode. So we go up here to find the anode. It would go from A and up here through F, E to D. So A, F, E, D. There it is. There's our choice. All right, next question. Which species acts as the anode when the reaction occurs in an electrochemical cell? So as soon as I see anode, I write ox, and I expect you to be doing the same thing on your paper as you take a test. I expect you to write these notes because they help you answer the question. So what is being oxidized? I know oxidation means losing electrons, and the oxidation number goes up. Zinc has gone from a 0 to a +2, so zinc is oxidized. And again, I make sure I am choosing the answer that is on the reactant side. I do not want to choose a product. Over here, the zinc ions are a product. I do not want that to be my answer choice. I want to choose a reactant. All right, number 9, oxidation reduction reactions occur because of the competition between particles for electrons. Oxidation is losing the electrons, reduction is gaining the electrons. In the reaction, the reducing agent. Now, when you see this word agent, agent means the cause of. So the cause of reduction is what is being oxidized. So you always want to remember that word agent means what causes this. So you think of the opposite things. What is being oxidized? So zinc is going from a 0 to a +2, so zinc is oxidized. So that would be our reducing agent. It causes the reduction. Over here, when the equation is completely balanced using the smallest whole number coefficients, the coefficient of mercury will be. All right, let's see what we have. We have 1 mercury, 1 silver, 1 silver. So right now the atoms are balanced, but the charges aren't. There's an overall +2 on this side of the arrow, and there's an overall +1 on this side of the arrow. So I would go here and I would put a 2 in front of this. and that changes it. So now my charges are balanced, +2, +2. That gives me 2 silvers, so I need to go over here and make this 2 silvers. So again, because that was on the 0, the charges are still balanced, and now the atoms are balanced. So in front of the Hg is simply a 1 when it is balanced. All right, next one. Given the reaction, what is the correct reduction? And reduction, remember, it is going down in oxidation number because it is gaining those negative electrons. So Cu is a +2, and it's going down to 0. Again, I want to make sure I choose the reactant, not the product. Oh, it's not having me choose just that. I did not finish reading the half reaction. So I want to make sure that I show reduction gaining electrons. This one here is showing the loss of electrons, and this one is showing the loss of electrons. So right away I can cross off B and D as answer choices. It is the Cu +2 gaining 2 electrons that brings it to Cu 0. So there is my answer choice right there, choice A. Number 13, in the reaction, the magnesium is the. So they're talking about agents and what is being reduced and what is being oxidized. So in order to do that, I need to put the charges on. Magnesium is alone, so it is at 0. Oxygen is alone, so it is at 0. Here the magnesium is a +2 and the oxygen is a -2. So the magnesium is oxidized and the oxygen is reduced. So it's asking me about the magnesium. So the magnesium is my reducing agent, meaning it caused reduction, and it was oxidized itself. So there it is, reducing agent, and it is oxidized. All right, next question shows an electrolytic cell. So an electrolytic cell tells you that it's a reaction that requires a battery. These, it looks like we are doing a little plating here, and we want to notice right away when they give us charges, and that helps us label things. So positive is going to be our anode. So this is my anox. And negative is going to be our cathode. So this one here is going to be my red cat. Next thing I like to do is draw those arrows. Oxidation, this would actually go into the solution, and then it would go and cover B. And my electrons would go this way through the wire. And then they would come down here and go this way through the wire. That would be my electrons. All right, the question says, when the switch is closed, what will happen to the 2 electrodes? So A is going to dissolve or break apart as it oxidizes. The mass will decrease. So I don't want that, and I don't want that. And then B is going to be coated in. Now, what ions are forming here? Sn +2. So tin ions are what's going to coat B. So A will dissolve, and B will be coated in the tin. There's our answer choice. Next question. In this electrolytic cell, electrode A is designated as the. So I got to go back. A. Right here, that was my anode. That's where oxidation occurs. So it was my anode, and it was positive because of the battery, because it's an electrolytic cell. It helps draw those electrons through, and it helps draw the, let me go back to the picture and show you. Helps draw these ions, the tin ions, to the cathode because it's negative. These ions are positive, and the fact that the cathode is negative, it helps draw them to it and helps plate it. All right, next question. Given the reaction, which describes the change that occurs? So I look at this reaction, I notice that copper is being oxidized and silver is being reduced. So I go to this. 1 mole of Cu loses a total of 2 moles of electrons. That's true. It's going from a 0 to a +2, so it's losing 2 electrons. That is true. 1 mole of Cu gains. Nope, we said it oxidizes. 2 moles of Ag plus loses. Nope, we said that it was gaining. And over here, 2 moles of Ag gains. It doesn't gain 1 electron, it gains 2. All right, number 17. A voltaic cell differs from an electrolytic cell in that it uses a chemical reaction to actually produce energy. So here it is, a redox reaction to produce electricity. Lots of times they'll ask about what is the conversion. So the conversion, if you are talking about a voltaic cell, it converts chemical energy to electrical energy. And if they are talking about an electrolytic cell uses electrical energy to allow a non-spontaneous chemical reaction to occur. All right, moving right along, number 18 here. Which species is oxidized? So I go up here and I need to look at what's happening. And I notice that this metal is alone, so it's a 0, and over here is a +2. So that is my oxidation that is occurring, and I want to make sure that I choose the reactant on the left. So I want to choose just the cadmium. 19. In which substance does sulfur have an oxidation state of +4? So here the hydrogen would be a +1 and the S would be a -2, so not there. When it's alone, it's at 0. Here, this oxygen would be a -2, so my sulfur would be a +6, so not there. Here, this would be a -2, 2 -2's balanced out with a +4. There's my answer choice. Number 20, what is the oxidation number of chlorine? So I like to write these ones out. HClO4. O is a -2, Cl is what I'm looking for, and H is a +1. You can set up a little algebra problem. +1 plus X, I only have one chlorine, so 1X, -8. 4 -2's give me a -8 equals 0. So then I would say X minus 7 equals 0 and X equals 7. So 7 is my answer choice. All right, here's another voltaic cell, and it says when the switch is closed, electrons flow from. So if you are not sure, which I'm guessing you haven't memorized the activity series, you go to table J and you look up Al and Ni. Al is higher, so this is going to be my anox, and this is going to be my red cat. The electrons will move in this direction through the wire. Ions will move through the salt bridge. This will lose mass as it forms aluminum ions, and this will gain mass as nickel gains atoms over here. So when the switch is closed, electrons flow from. So they are going from this Al electrode over here to the Ni electrode. I cannot choose the solution because the electrons go through the wire. So I have to choose that they are going from the Al to the Ni, solid to solid. It's really important that you choose the solids and not the ions because electrons traveling through a wire are not in a solution. What is the oxidation number of chromium? Here's another one of those algebra problems. So I've got K2, Cr2, O7. Oxygen is a -2, Cr is what I'm going to solve for, K is a +1. 2 + 1's give me a 2, 2 Crs give me 2X, and 7 -2's give me a -14. I set it all equal to 0 because there is no charge. This is a compound. And now I go 2x minus 12 is equal to 0. So 2x is equal to 12. So x is equal to 6. And I choose my answer. Next one. Which process requires an external power? If you need a power, that means that you are using a battery. Batteries are used for plating and for splitting substances where it is a non-spontaneous reaction. That is known as electrolysis. The word lysis means to break apart, and that requires energy. All right, last question here for today on redox review. Which expression correctly represents a reduction half reaction? Reduction is gaining those electrons, so right away B is showing the loss of electrons and D is showing the loss of electrons. I want to balance out my charges. Here I have a +1 and a -1, and that's equal to 0, so that is correct. Here we have -2 on this side and only a -1 on this side. That is not equal, so that cannot be our answer. Please make sure that you come and ask me for extra help if there is something that you are not understanding.